moving on, to find the magnitude of the vector, we want to calculate the distance between the initial point and the terminal point. So the magnitude of the vector we said before is denoted with that like double absolute valued, right? Oops, come on. Let's rewrite it. So the magnitude of V is the absolute value to double absolute value of V. All right, so we can compute it using what's essentially Pythagorean theorem, right? So we know the x component, we know the y component, so in order to figure out the length of it, we use Pythagorean theorem. So this is going to give us another rule that we could take advantage of. Okay. If you guys hear my cat, she's like screaming in the background right now. Sorry about that. So if V is our vector x comma y, then the magnitude of V is equal to the square root of x squared plus y squared. So note that because this vector is written in component form, it's equivalent to a vector in standard position, with its initial point at the origin and terminal point with coordinates x, y. It suffices to calculate the magnitude in standard position using the distance formula to calculate the distance between the initial point and the terminal point. This is what we end up with. So based on this formula, it's clear for any vector that its magnitude is going to be non-negative, and it equals 0 if and only if our vector V is the 0 vector. So these are just some of our properties. Right, we're calculating the square root, so we're forcing it to be positive. So I'm using that IFF, and that just means if and only if. So the magnitude of the vector can be derived using Pythagorean theorem, as you see right here. We've defined scalar multiplication and vector addition geometrically. Expressing vectors in component forms allows us to perform these same operations algebraically. So let's sort of write out these definitions then for how we do scalar multiplication and vector addition. So vector multiplication is different, and we'll get to that in the next section. So let V equal the vector with our angle brackets with x1 and y1 as its coordinates, and vector W be our components x2 and y2. These are vectors. And let k be a scalar, right? So that just means it's any real number. Then, scalar multiplication. So we've already said it's written kv, right? And so now we have a formula. We're just going to multiply k by our x coordinate, and then multiply k by our y coordinate. Nicely done. Vector addition. Well, we said before, right, that we're just sort of throwing the endpoints at one end to the other. So we're adding the x coordinates, and we're adding the y coordinates. So that's all we need to do. All right, so now let's take a look at an example.